Welcome to GoggleCam, the internet's first-person video of how to do lab.
We have a Rigaku MiniFlex, which as you can see is tabletop or benchtop model, and this is, because it's so small and therefore portable, it's used by forensic science teams to use on site for analysis of gunpowder, residue, and things like that. To start the instrument, we go to the back here where we have a voltage controller. We switch to 120 volts. So this regulates the voltage from CWLP before it goes into the instrument. And here we have a circuit breaker, which we turn on, and then we press this black power button. So you can hear the fans are starting and the lights are turning on. So we have power, the shutter is open, but the instrument is not ready, and that's because if we look here on these set of warning lights, CW, the cold water, is not running. So the next thing we need to do is turn on the cold water circulator, which is there's a heat exchanger here with air with this water. So we want to check our water tank, make sure the level is high enough, it's above that second hole, and that it's clear. We can see all the way to the bottom. There's no debris or growth that we can see. So that checks out. Next we turn on the power here, and if there's nothing blocking the flow, the pump should be at 50 psi. And now we'll set this out so it can exchange with the air and keep the instrument cool. The X-ray generators at 30,000 electron volts, which is a lot of energy, would melt the anode unless we keep it cold constantly. So now you can see that the ready light is on. We can turn on the X-rays, and you see that the red light goes on here, the red light goes on here. If anytime during the experiment you need to shut it down because of some emergency, that's what this big red knob is on front. You just push that knob to instantly shut down the power and stop generating X-rays. That's not the normal way to shut it down. I'll show you later how to normally proceed to shut it down. But when we open this door, you see the shutter light is on, meaning the shutter is open. When we open the door that closes the shutter, we can get access to the sample chamber. And so let's take a look at what we have here. The shutter is closed because of a mechanical linkage between the door and the shutter, so that there's no X-rays being generated into the sample chamber area. We have a sample changer mounted that looks like an old CD changer. On the left here is our chromium X-ray tube. Our X-rays are being generated there, and it's being kept cold all the time with the water, or else it would melt. This is the shutter that blocks the X-rays. Our sample goes right here. Then there's this arm that's going to rotate, and on the end of the arm is our X-ray detector, or scintillation counter, and in front of that is a film of vanadium that will block the K-beta radiation from the chromium. So now let's get our sample in position that we already prepared. And you can see the two magnetic pins will lock the sample down into that metal ring in the sample chamber. And the sample surface is level with the reference surface here in the sample holder. So now we'll close the door, which opens the shutter. We'll press the reset button to clear the electronics to go to the computer. If you need to, you can log into the computer using this login ID and password. We're going to use the standard measurement software, which is here or here. And I have each line is associated with a sample position. So again, if we look here, our sample is in position number 1. So sample 1, we want to use this first line, yes. And we want to print Let's make sure the printer is on here and plugged in. We'll save it to our class folder. Give it a file name of 8 characters. And so that's our sodium chloride ground sample. And this is clunky, so you have to enter it a certain way or it won't keep. It's definitely not liking... Oh, maybe I can't have a comma. There we go. The attachment is going to do number 1. So attachment number 1 condition means it's going to rotate. So yes, that's what we want. And then the scan condition is number 3. So let's look at that. Scan condition number 3 is for our class 20 to 120 degrees, 0.03 degrees per sample at 5 degrees per minute. So yes, that's the one we want to use. And so once we're satisfied that that's set, nothing else is going to happen, we execute the measurement. Start the instrument. No, I don't want to overwrite the data. Let's see, let's call this something else. Try again. Okay, so it's going to initialize, and if we look over here, we'll see the sample is turning, and that arm is there turning. That angle there is the 2 theta. So here we see this is the live signal from the instrument. On our y-axis is intensity and counts per second. On our x-axis is degrees 2 theta. So the angle between the X-ray beam and the sample is theta, but then the detector is moving here, and so the detector will see at angle 2 theta, and that's standard